I know, I know. Can you hear my audio? Okay. All right. Does the S stand for Shri? My favorite phone user. I know there's so many. All right, I can start answering your guys' questions. You can just put them right in the chat here. My favorite phone user. I don't know. There's so many. Lengths of right angled triangles. Question 4. Oh yes, yes, yes. All right. Give me 1 second here. I just have to load up that worksheet, Christine. Christine, is it this one here? Okay. So, wait, no. It doesn't really matter, I guess. They're all about the same. I can do some, if you want practice on lengths and angles, I can do some angles with you now and then do some lengths as well. It's up to you. Okay, I'll pick some angle questions to try out. Let's look at number 4 of this 4. So this one. So for this triangle here, you'll see some of these on the test as well tomorrow. So they're asking for angle, right? They're asking for angle theta. So once you find your angle, label it. So directly opposite, label it your opposite. Across from the 90 degrees. Always look for your 90 degrees directly across from the 90, label it your hypotenuse. And then the leftover one's your adjacent. So with this one here, Christine, I've got the 10 and I've got the 11.9. So that involves the O and the A. So of your abbreviation here, you're going to choose this one. So this is going to be tan. So the tan of theta is your opposite over your adjacent. Right, so now you want to take the tan inverse because you want to solve for theta. So take the tan inverse of both sides. And then you can solve for theta itself. And if you punch this in, my calculator is in degrees. Make sure your calculator's in degrees tomorrow. I get approximately 49.56. Are there any questions with that one? I'll pick a couple more, but... it depends on your calculator. Like, I've got tan, so like for my calculator, for most of them, you hit second function. And usually in the top left-hand corner of your calculator. Well, this was not supposed to be a calculator, but... Oh, same one. Okay. Well, I have another one on me. I don't know where mine is at. The one that I've used with you guys. But the top left hand corner, there's a second function button. So you hit the second function button, and then you hit that button tan, because you'll notice the button of tan in this case, it'll say tan, and then right above it, there'll be like a tan inverse. And that's representing your when you hit second function. So you'd hit second function, tan, and then you put your brackets, left bracket, 11.9 divided by 10 right bracket, you'll get, as long as you're in degree measure, you'll get 49.56. Here, I'll pick another one for Christine here. I don't know, let's look at like 8, for instance. If you look at 8. So now my angle's all the way up here, but it doesn't really matter. Once you find your angle, you label it. So directly opposite, you label it opposite. Across from your 90 degrees is your hypotenuse, and the leftover is your adjacent. Yes, you only do inverse when you're finding angles. Very good. So this one also involves the O and the A. I'll do a bunch more, but this involves the O and the A. So you're going to go tan of theta again, because it involves O and A is opposite, which is 3, over adjacent, which happens to be 3 as well. So here you get tan of theta is 1. And then you're going to go ahead and take the tan inverse of both sides. This is a nice value. You know already that this is going to be 45 degrees. But you can punch it in your calculator, and you'll also get 45 degrees for that one. So that measures 45. Okay, so there's 4 and 8. Let's try 7. Will give us something other than sine. Like if we're looking at 7, you're going to grab this angle here, theta, directly opposite, label it your opposite. Find the 90 degree angle. Across from that is hypotenuse, and leftover is adjacent. So then highlight what we got. I got the 4.4, I have the 11. That involves the A and the H. So this will be cos this time, because it's A and H. So this will be the cos of theta is my adjacent over my hypotenuse. And then again, take your cos inverse this time. So once again, you'll hit second function on your calculator, cos inverse, or second function, then hit the cos button. That'll get you your cos inverse. So in this case here, if I take the cos inverse of 4.4 over 11, making sure I'm in degrees, I get 66.42 degrees. Good. Christine, is this good so far? Did you want to do another angle question? Or if there's any other questions, you guys can ask as well. I can't tell you what's on the test, but I can take up the swing question. Okay, did you want to do lengths, Christine? While I'm on this page, I can do lengths if you want. Like I'll pick a couple of these lengths. As a reminder, guys, this will record for you, so you can rewatch this stream. It'll as soon as we're done the stream, it'll record it, and you can re-review it if you need to or whatever. Here's 15. So for 15, they want us to find x. Right, I'm looking to find x. This is my reference angle, 37, so directly opposite. The same thing, label it just like you did in the previous 2 or 3 examples we've done. Label this opposite, adjacent, hypotenuse. Now in this situation here, this involves the O and the H. So O and the H is sine now. So this will be sine of what? Now that we're looking for length, we actually have the angle. I know it's 37 degrees. So the sine of 37 degrees is my opposite over hypotenuse. And now I'm looking to isolate for x, so there's no inverse to be taken here. Multiply across by 10.3, and I get x is 10.3 sine 37. So if you punch that in on your calculator, I get 6.20 approximately, and I don't know what this is measured in. Good. That's 15. I can grab another one. Perhaps 14. Here we can, let's see, 14. Yeah, let's look at 14. It's a little bit different if you are looking at 14 here. Christine, did you want to try this one since you're the one asking? Hey. Sure, try it. Yeah, go ahead. Try 14 and 16 if you like. Do 14 and 16, and I can take them up. Lon. Oh, hey, Kinlon. How are you? Hey, Dia. What's up? I'm okay. I'm not too bad. It was like really cold today, so I didn't do much. Dia, you gonna watch the Lions game at 8:30? Kinlon, how about you? Guys, any questions? Oh, I guess you guys are doing 14, and here, I'll write up a solution to 14 here. You did. Opposite? No, that's the Michigan game, Dia, you watched. The Lions game is tonight. Yes, Michigan did win. Opposite, hypotenuse, adjacent. Okay, so this is the O and the H here. So this will be sine. So this time we have that this is sine of 57 as opposite over, I don't know. So now in this situation here, what you want is in the bottom. So you guys always have trouble solving this. You always want to put x equals 10.8 sine 57. This is not the case. You got to multiply across by x. And then divide by sine 57. 0.8. And see what we get here. Sine 57.8. So I'm getting 12.76. 12.76. Could I do some examples with word problems? Yep, for sure. This will be our last from the lengths one. Christine had threatened me if I didn't take up angles and lengths, so I'm going to do those. Here's 14. Christine, can I do 16? We good? So opposite, adjacent, hypotenuse. If I want? Oh. Okay, are you getting these? Then I can move on then. This will be cos of 47 is adjacent over hypotenuse. So in this time here, what I want is in the top. So I multiply across by 3. And, oh, good for you. All right, I just wanted to make sure before, because I'm on the page. If anyone else needs these, I can move on to word problems as well. And done. So that's about it for lengths and angles here. Okay, so you'll see a couple of those on the test. Solving for lengths and angles. And I think that's it. I'll move on to word problems now for you guys. problems. Here we go. Okay, here's word problems. All right, what did you guys need from the word problems? What would you like me to go through? Sir, can you do the swing question? Ferris wheel question. Oh, sorry, I'm not talking to you, Siri. Sure. Swing, Ferris wheel, here it is. Okay, I'll add this here. Here you go. Oops, sorry. Okay, swing and Ferris wheel question. Sure, let's do it. I'll just... let me just change this into 2 questions here. Here's a question. Here's a question. All right. I am ready. Okay, here's the Ferris wheel question. So with this Ferris wheel question here, you've got this swing. This actually wasn't, this 1.7 was not labeled in the question. In the original question, they only gave you this as the 1.7. But the idea here is if that rope, string, or swing handle is extended all the way around, these will all be 1.7. In particular, this length here is 1.7. Like to the, from here to here is 1.7. If here to here is 1.7. So they want you to find the distance of the person to the ground. So that's going to be like from here to here. This is what we want to find. I want to find the distance to the ground. Like I can label that with like H or something. This is like what I want. To find that, what you want to do is you want to find this length here, because if I can find this length here, I know the length from here to here is 1.7 and here to here is 0.3. So I know the length from here right to the bottom. I know what that's exactly 2 meters. So if I can find this length here, I can just subtract the 2 and I'll have what the length in purple that we're looking at. So that's what we're going to do, is I'm going to find that length first. But we've just identified that this is 1.7. This is a right angle. And they tell me in the question this is 70. So this is just a basic right angle triangle to solve. This is my opposite. This is my hypotenuse. And this is my adjacent. So therefore, this involves the hypotenuse. And I want the adjacent. So I'm going to highlight that. So that involves the A and the H. It's going to be cos. So this will be the cos of 70 degrees is my adjacent over hypotenuse. And then you're just in the exact same situation again. You want to solve for x. So x is 1.7 cos of 70. And you just punch that in on your calculator. 1.7 cos 70. I'm getting 0.58 approximately for this. Good so far. I can't remember who asked the swing question. Oh, hey, Kinlon, if you're there, I forgot. I told Yiwei to say thank you for the little miniature turtle you got me. But thank you, Yiwei, or Kinlon, if you're there. Thank you very much. I added it to the... Okay. Thanks for the little turtle. I added it to the other one. So there's like the turtle, and then Yiwei got me the other turtle holding a turtle holding a turtle. Is this good? Okay, so this isn't done here. Turtle collection, yes. This isn't done here. Studying account person. This is not done yet. The 0.58 is the x. So my answer, the distance to the ground is 2 minus 0.58 would be our answer. right? Because you got to subtract those. So that'll be 1.42 meters if you subtract those two numbers. Oh, someone is Yue based on my deductive reasoning. This must be Yue. Okay. Gotcha. Are we good? So there's 13. Oh, you got it. Okay, great. Thanks, Ina. So there's 13. I'm glad that's helpful. 14 is the same thing. Like, I think in the question they want you to find all of the distances to the ground, and I think what I did was I think I posted the answers for all of them. So if there's, I don't know if there's specific spots you're interested in looking at. Like I could find this distance to the ground and maybe this distance to the ground. And if you're looking for something different, I could do this one. Not sure. But on the test, you'll see a Ferris wheel. Like as a reminder, the Ferris wheel does not have to be, like this Ferris wheel has 12 sort of slices out of it. Like there's 12 of them here. Sure. Okay, for sure. Let's look at the ones below since you're asking. So I don't know, this one and this one. Let's look at these three. So if we're doing the ones below the like midpoint, here your diameter of your circle. Let's pick one of these. Like if I wanted this one. So if I'm looking at the distance of this to the ground, it's kind of like the Ferris wheel question where I had to find this and then subtract. It's kind of the same idea. With this one, I'm going to find the distance. Like if I can find the distance from here to here, right? If I can find that distance, let's label that with an X, then I know the distance from here to here is equal to what? Well, the diameter of the circle is 20. So all of these are 10 apiece. These are all 10, 10, 10, 10. So that means the distance from here to here is 10, and this is 3. So 10 plus 3 is 13. So I know the distance from here to here is 13. So if I can find the distance from here to here and subtract them, I'll also have my answer. So you do the same thing. You draw yourself a little triangle. All right, and I know this is 10. I want to find x. I just need to find this angle here. But like we talked about, the whole distance around an entire circle is 360, and there's like 12 of these little triangles here. There's 12 of the triangles if you count them up. On the test, there may be different. You have to divide by a different number. So I know that this is 2 triangles. This will be 60. So again, it's just back to right angle triangle. This involves your opposite and your hypotenuse, so it's sine. So this would be the sine of 60 degrees is x over 10, and that implies that my x value is 10 sine 60. And if you go ahead and do that, the sine of 60 is root 3 over 2, so times 10. I got 5 root 3. I wanted to get it as a decimal place. Let me see here. Can someone give me that as a decimal place? It should be 8 point something. I'll just mention it here. Thank you. Yeah, you get 8.66 here. Thought it was something like that. So you get 8.66. So that's not my answer. My answer, we'll call this 1. So for 1, the answer is going to be 13 minus 8.66. in which case you get 4.34 meters for this one. And that becomes the distance. Oh, is it cut off on your screen? I'm not sure, I can't. On my screen it looks like it's cut off. Can you guys see the bottom of the thing here? Oh, there you go. Okay. For person 2, person 2 is pretty easy. It's right at the bottom, so the answer is just 3 meters right on. And person 3, the little green one I made, it's the same idea. The green person, you're getting one of these on the test, the Ferris wheel question. So for the green one, you want the distance from here to here. The same idea, find the distance from here to here, and then subtract. So this is 90 degrees. So if you want to like kind of draw a triangle off to the side, you can do that. This is 90 degrees, and in which case I'm looking for x. All right, I'm looking for x here, and I know this is 10, and this time that triangle is only 30 degrees. Right, so this is going to involve the O and the H again. So this will be the sine of 30 degrees is opposite over hypotenuse, and x is 10 sine 30. And you know the sine of 30 degrees is going to be a half, so this is just 5. Like if you punch this in on your calculator, you're going to get 5. So therefore, the answer for this one, you have to subtract it again, so it'll be 13. Instead of 13 minus 8.66, it's 13 minus 5, and the answer is 12 meters. Do you guys see all these emojis here? What is this? Are you guys seeing that? What is that doing? Interesting. All right. There's a Ferris wheel question. Any other problems I can go through that people need? Oh, I see. Oh, okay. Oh, I see those. Okay, we're laughing. Are we laughing? Or crying? I'm not sure what that is. Oh, it's a laughing one. Okay. Interesting. This is new. Number 9. Zena wants number 9. Is that the airplane? Oh, no. You're probably asking 9 from the original sheet here, this one? Probably, I bet. Okay, so number 9. Let's check it out. Okay, so the answer was 57.32 with number 9. Let's try to draw this. So you got from a position 10 meters above the ground. So from a position 10 meters above the ground, the angle of elevation to the top of the building is 45. Okay, so you've got like this like block you're standing on. It's like 10 meters. And then you have this building. And you look up at the building, and that angle of elevation is, in this question, it's you're 10 meters above the ground. Oh my gosh. No, I didn't mark the tests. In fact, I didn't mark them, and I left them at the school. I'm not even sure where they are at currently. Who knows? The Alex store. Oh, yes. We can do a snowman. That was the deal. Yeah. So with this one here, you can bring what you want. We'll make a snowman and buttons, yes. Yes. 1 second. So with this number 9 here, 10 meters above the ground. So you look up at the building, 45 degrees. You're good. And then it looks like you're 20 meters higher. So by 20 meters higher, they mean like you're extending this another 20 meters. And then you look up at that exact same spot, and that's at an angle of 30 degrees to the ground. That's at angle of 30 degrees to the ground, and we want to find the height of the tower. So we want to find this entire height here. So the observation with this one is I've already got here to here is 30, right? So if this is 30, I know this is 30 on this side. So really what I want is I really just want to find this length here. So I can label this with my h. I'll let that be my h because that's really what it is. I just find my h and, oh, upside down smile. Interesting. I find my h and add 30. So with this one here, we'll do the same thing. Now, the reason why people get thrown off is they don't, there's not another variable, but it's much like 6 and 1. You have to introduce another one. Like I can call this d, for instance, the distance between the buildings. So what I'm going to do is I'm going to set up a ratio, 2 triangles here. I've got a triangle going this way. Oops, sorry. I've got a triangle going this way, this big triangle. This will be the tan, right? This involves O and A. So it'll be the tan of 30 degrees is my opposite over my adjacent. There's 1. And then you do it again for the larger triangle. And this time it'll be the tan of 45 degrees is equal to my opposite, which this time the opposite is going to be h. Just watch out here. The opposite's going to be h plus 20, right? Because don't forget this is 20. So to do the bigger triangle, the opposite is all of this. So h plus 20, again, over that same variable d. And then I want to solve for height here. So I'm actually going to isolate for d first and just set those equal. Just might as well find the distance between the buildings. So I know that d tan 30 degrees is equal to h. So I'm isolating. And then here, Zena, since you were asking, I'm going to get d tan of 45 degrees is h plus 20. So h is going to equal d tan 45 degrees minus 20. So I've got these 2 equations here. So the problem is you can't solve for it directly until you get to the next unit, non-right angle triangles. So you're kind of stuck using right angle triangles. So now I set these equal. I get d tan 30 degrees. What's this here? Would it be h plus 10 because it's at a halfway point? No, it was 10 first and then it was 20. So this is 20. So like I'm interested in this triangle. There's no halfway point. Like they don't say midpoint or anything like that. So I'm here. Tan of 45 degrees minus 20. Now we're lucky here. The tan of 45 degrees is 1. Because at that 45, if you go back to your unit circle, at 45 degrees, sine and cos are exactly the same. So you're gonna get 1 here. So this is actually d tan 30 degrees is equal to d minus 20. And I'm looking to solve for d, so I bring the d's to one side, keep the numbers to the other, and then I can factor out that variable of a d. And then this is just a number, like tan of 30 minus 1 is just a number, so I divide that out just as you would any other number. And then we can get a value. This is not my answer. This is giving me the distance between the buildings. Tan 30 minus 1. Okay. My calculator is giving me, here we go. All right, someone let me know if they got the same thing. I'm getting 47.32. 47.32. 0.32 approximately. That's not the answer. That is the distance between the buildings. Sub it back into either equation. I'll just sub it back into equation 1 because it's a little bit simpler. So you're going to get approximately 47.32 tan of 30 degrees. And I can get my height here. 47.32 tan 30. And punching this in, I'm getting 27.32. That's, again, still not done. That's the height, but then you have to add the 30, remember, because that wasn't the full height. And the answer is 57.32, and that's what I had said the answer was earlier. And that's it. Just a little celebration there and done. Randy Johnson. We've kind of done several of these already, Xena. Make you appreciate non-right angle triangles formula much more. But there's 9. Anything else I can go through, Mr. Johnson there? We'll have to do that. I'll come back to this at the end. I just did a bunch with Christine. So if you go, it's saving. This is all saved. So if you go back, I did maybe about 6 examples of angles and lengths of sides. Sophia's here, and Dow. In more questions, January 12th for questions. Can you do questions 13? Is it going to be on the test? Okay, sure. Yeah, that's, you're looking for, sorry. This one right here. For what questions are on the test, I had kind of outlined, you're going to get a chunk of solving for angles and lengths of sides, and then there'll just be a bunch of word problems. The word problems come from the homework, so there's all like homework style word problems. I mean, there's a lot of different questions you see here, but they're all really the same question. If I look at 13 here, it says an airplane climbs at an angle of 18 degrees to the ground. So it's kind of like you've got a ground, you've got this airplane, it's leaving at an angle of 18 degrees to the ground, and it says find the ground distance, and the plane travels as it moves 2,500 meters through the air. This question here, there's nothing wrong with the question. They're just using a bit of language that maybe you're not familiar with. By ground distance, they're referring to your horizontal distance. I mean, if I ask a question like this, I'd word it a little more clearly in terms of something you're more comfortable with. But I believe this is what they're getting at here. Airplane climbs at an angle of 18 degrees to the ground. I think that's fairly straightforward. But it says find the ground distance. That's your horizontal distance, like how much of the ground, when the plane's traveling, what's its ground distance. As it travels 2,500 meters through the air, I'm assuming that's the distance the plane traveled, is the 2,500 meters through the air. So once you have it set up, I'm sure it's easy now because that involves your adjacent and hypotenuse. So this would be the cos of 18 degrees is d over 2,500, right? So therefore, the ground distance is 2,500 cos 18 degrees. But nothing wrong with the question. It's just like, I guess the wording's can be a bit challenging. You guys were fine. I think you guys did good. Class average was good, 50% or something like that. No issues at all. You know what, Sophia? I already did the Ferris wheel question. So it's recorded for you. So when the stream's done, you can kind of scroll back and check out the Ferris wheel question. So it's done the Ferris wheel one as well. So I'll just like continue. There'll be no diagram on the exam. Or on the test. You have to draw your own diagrams, but all the questions are very similar to the ones that you've done. So I was joking. I didn't mark the test. I'm sure you guys did very fine. Did well. But for the exam, I'll stream for everyone again, so I can help you guys leading up towards the exam. I'll give you 2 or 3 help sessions. Pooh. Okay. Is there a question on the test with north-south thing? I can't tell you what's on the test, but nothing more complicated than the example I had given you guys for that. The Ferris wheel will be drawn for you if it's on. Thank you for asking. That's a good question. Question 7. Is this from the original worksheet? Dr. W-A-S-D. Like this 7 right here, the baseball diamond? Oh, from the new sheet, sure. 7. You know what? You guys can't answer 7. January 12th, more questions. Miss, can you go over the unit test because I said. Sophia, you're asking for January 12th more questions example 4. Nah, don't worry about it. That'll be another we'll just do that later. That'll be the next unit. It's much easier going through the next unit. Right angle triangle word problems. Okay, not this one. Right here. Oh, for number 10 here, the one that you're asking, find the measure of the acute angle. I took it up in class, but I had said to the class they don't have to worry about doing it like on the test. But yeah, that one, the diagram looks like this. It's fine. It's not a big deal to answer it. But I won't put it on the test, no. I'll post a solution. I have a solution posted of it, but 10 I won't put on the test. Ali Zeter. On the test, is there going to be... Sorry, there's this... No, there won't be just word problems. There'll be word problems and then some angles and lengths of sides to fill out. There you go. Thank you. No tippity top. Just right from the homework. No. No need to suffer. Much more time for that later. Okay, so I would know like the building questions. These ones are pretty good. I'm not saying it covers everything you need. I think this will be our last assessment. before the exam. We can see, but let's just focus on tomorrow's test. But what you need to know is make sure you can find lengths and angles of right-angled triangles. Oh, sorry, who's asking? Sir, I'm suffering. I'm not getting an answer to my question. What's your question? How do I know what to draw for each problem? Yeah, I've already said that. Like the problems are like the homework. So, you know, all the homework, the diagrams haven't been drawn for you. So you would have had lots of practice drawing the diagrams, and you'll get similar questions with similar diagrams. You guys want more assessments? I thought you want less assessments. I don't understand. You want more tests? Isn't less tests better? Sure. For you, Ion, number 6, done. But there's no such thing as a quick version of number 6. Number 7, I'm not sure. Sorry, Sophia. Okay, here is number 6 here. Ion was asking number 6. So trying to measure the angle of elevation found to be 10 degrees. So there's like this building here. Got a building. Donna looks up, sees the top of the building. Angle of elevation is 10 degrees. Then walks 100 meters. Looks at that building again. And I had put in the 50 degrees this time. And what they want us to find here is the height of the building. So you've got all this set up here. Snowman. We're building a snowman on Monday. That's our big task for Monday. Okay, so we'll go ahead and solve this. So this one here, they want the height of the building. It's kind of like number 9 that we had done for Xena, except for it's kind of in the horizontal direction instead of the vertical direction. But it's the same basic idea. Like, I'm going to let this be X, and then you set up 2 triangles here. Like, I've got the smaller triangle. So in this case here, for 1, the tan of 50 degrees is H over X. And jump in, Ion, if you're confused. I'm taking the smaller triangle. So you're going to do tan of 50 degrees is H over X. And then the tan of 10 degrees here, tan of 10 degrees, is H over 100 plus X. So now just like 6, you have that same sort of idea. And again, this question will be much easier when we do sine law and cosine law next unit. But this is just the way it is. So this becomes X plus 100 tan 10. So exactly same sort of idea. I've kind of isolated for H in 2 different representations. I can set them equal. And I can solve for X, which is actually not what I want, but I can use that to eventually solve for H. So this becomes X tan 50 degrees is X tan 10 plus 100 tan 10. So I want looking to solve for X, so X is to one side. And just kind of yeah, guys, don't worry the exam. We have our mark here, and then we have our exam. Lots of time to change your mark, bring that mark up. I can adjust the exam weight for sure. Not to worry. Don't need to be stressed out. Go like that. And then we can solve for this here. So, Ion, I was kind of talking at the same time, but are you getting the general idea? Right, so I used the small triangle, set up my ratio, did the same. Step right into here. Then you set these equal. Well chosen words, Sophia. Very smart. Smart lady. So now set these equal, and then I'm distributing the tan 10 into the binomial. X is to one side, factor out the x, divide it out, and then you're going to have to punch all this in on your calculator. It's going to be messy. Here. Delight. Very nice. So I end up, whoa, what did I get? Just 1 second. Okay. Did anyone else punch this in? I've got this calculator here, not my. Oh, there we go. I'm getting 17.36 for x. So that's my x value. I don't know if I've lost Ion, if he's still here, but this is his question. I didn't know people still play Fortnite. That's good. So the height is x tan 50. So this will be, it's not an x. I found out the x, it's 17.36 tan 50. And then I can get my h value here. So I'm getting, this ends at 8:30, by the way, so 5 minutes or so. I got 20.69 for the height of this building right there. Yeah. Yeah, 6 is from the homework, and 9. That would be the hard, one of the more challenging questions on the test. But there's also the straightforward stuff as well, that you have to know, right? So make sure you can do that too. You're welcome. Is there anything else? You know, the building question, I'm sure you'll see some buildings on the test. High chance of a building popping up on that test. Is there anything else I can help you guys with? I know we had spent most of Friday reviewing as well, so I'm sure you guys are pretty decent at this. Everything's split up pretty evenly, Sophia. Everything's split up pretty evenly, but you're gonna get maybe 12 marks or so in angles and lengths of side. Just I'll give you a bunch of triangles, find the lengths and angles of a bunch of the triangles, and then it'll go to word problems. And the word problems are just going through. I think they're usually about 5 marks each or so. Can't quite remember off the top, but there'll be a bunch of word problems. There'll be some quick ones, and then all the ones like, you know, take a look at this first worksheet. Would be my recommendation. 1 to 9 would be good practice for preparation for the word problems. There may be some other little word problems as well. You know the Ferris wheel question's on. I've already told you that's on, so be okay with that. And that's it. 12. Is that the bowl question? Sure. All right. I was hoping to stop at 8:30. Can do one more. 2. Oh my goodness. The bowl question, they want you to find the depth of the bowl. What's going on in this bowl here? So this is what they want you to find. That's just the radius of the circle. So the idea here is I know the distance from here to here is 20. That's the radius of the circle. But that is also, because it is a circle, that's the distance from here to here is 20, here to here is 20, and most importantly, the distance from here to here is 20 as well. So I know that the distance from here to here is 22, like 20 as well. So, you know, I want x from this diagram. So it's the exact same trick that we did for the swing and for the Ferris wheel when you're below the middle of it, when you're below your main diameter. You know the length from here to here is 20. So if I can find the length from here to here, I can subtract it, and I can get my answer here. So I'm going to draw my little triangle, and this is 35 degrees. I want to find this variable just so there's, here, let me erase, oops. Let me go here. I want to find this. I know this is 20, so you can set up a ratio here. I know the sine of 35 degrees is x over 20, i.e. x is 20 sine 35, and then I can actually find my x value. I think the test is out of 38 marks or so, and I'm getting 11.47. Now that's not what I want. I want this length here. So let's call this t or something. To find that, my answer, you take 20 and subtract it by the 11.47, in which case I'm going to get 8.53 meters? Or not meters, centimeters. That'd be a pretty crazy bowl if it was in meters. This would be insane. Okay, there's the bowl question. All right. All the marks tomorrow, guys. 100%. Number from right angle triangle worksheet. 3. I'm not even sure what one that is, but I see no 3 here. Oh, the original worksheet? I should label these better here. Oh, number 3. Right here? There we go. Okay. Okay. Alright, this will be the last one. I'll save this for you. You can check it out in... So as soon as this is done, it'll save it all for you. And then you can rewatch it over and over again a million times if you like. It's all there for you. So this question here is a similar triangle problem. Yeah, it's a similar triangle problem because you've kind of got like a situation like this where you have a 1.8 tall meter person is casting a 4 meter long shadow, and then a 2.4 tall meter person, they want to know how long of a shadow is this person casting. So this is a similar triangle, right? The small triangle, the big triangle here are similar to one another. They share a corresponding angle, and these angles are the same, so leftover angles are the same. Triangles are similar. So since they're similar triangles, you can do the length of the big triangle, which I'll just to make it a little cleaner, I'm going to label this as an X. So the length of the big triangle is like x plus 4. That would be the length from here to here, divided by the length of the small triangle. So that would be the length from here to here. Must equal the length of the big triangle, which is 2.4, divided by the length of the small triangle, which is 1.8. So therefore you get x plus 4 is 4 times 24 over 1.8. And this ends up being here 4 times 24 divided by 1.8 is that right? And then if oh, that's 2.4. Sorry guys, I was looking at my answer, like this is not coming out to be the same as what answer I provided. So I get x plus 4 equals 5.33, and therefore, well, I'm not really, I labeled this as x, just so there's no confusion. I labeled this as x from here to here, which is not what we want. I want the whole thing. So x plus 4 is actually what I want, and the answer is 5.33. So the answer is 5.33, but that's how you get it. I probably should have labeled this whole thing with an x, but I had just labeled this, so I still have to add the 4 anyway. So there's no point to solving for the x. That's just the distance between the two people. And that's it. All right, that's it for me. So I'm going to end the stream now. This will save everything so you can check it out. Okay, wishing you all 100% tomorrow's test. Should be good. And we can go ahead and I'll save the stream. It should load right under live if you want to rewatch it. I know Sophia and some other people earlier were asking for certain questions that had already been done, so you can review those if you like and check them out. So good luck, guys, and I'll see you tomorrow.